Hey everyone, so welcome to today's lesson. Today's lesson, we are on lesson 1-6. In this lesson, what we're going to learn is to determine whether a function is one-to-one, but also be able to find the inverse of a function. Our language objective is to explain how we find the inverse of a function. So let's take a look at our do now. In today's do now, we have been given two questions. We have been asked to determine if the following are one-to-one functions. So I'm going to make you guys pause the video and let's see if we have the same answer. For number one, we can tell that this is not a function, and since it's not a function, the domain repeats, we do not need to find that one-to-one piece. So I am done. For number two, we do have a function. Once I find out that this is a function, then I could find out if it is a one-to-one function. In this case, it is. So for today, what we are going to be thinking about is what is an inverse function and how do we find it? So what is an inverse function? Let's see. An inverse function is a function that will undo anything that the original function does. If a function is not one-to-one, it does not have an inverse. Very important for us to understand that. Our link here is, now that we know whether a function is one-to-one, if a function is one-to-one, we could find its inverse. If we find out that a function is not one-to-one, therefore there is no inverse. So what are our steps? What we are going to do is we're going to write the function in terms of x and y. Switch the input and the output. Solve for our new y and write our answer in proper notation. The notation that we're going to be dealing with is not in terms of y equals. We're going to be dealing with functions in terms of function notation. So if my original function is f of x, the inverse you write as f with this little -1 on top, like an exponent. That represents the inverse. So let's try example number 1. So in example number 1, we have been given the function f of x to be some linear function, 1/2 x plus 8. We want to algebraically determine if f of x is a one-to-one function. And if it is, then that means that we could find the inverse. For part A, we want to algebraically determine whether this is a one-to-one function. So how do we do that? In order for us to algebraically determine this, we want to show f of A equals f of B piece. We're going to substitute. So if this was my equation, I will minus 8 on both sides. At this point, I would multiply both sides by 2, canceling out my 1/2, giving me that A equals B, and we know we have a one-to-one function. So that's for part A. For part B, what we want to do now that it's a one-to-one function, so first thing I'm going to do, I'm going to change my equation in terms of x and y to simplify my life. At this point, I'm going to swap my x and y and solve for my new y. And I get my equation of y equals 2x minus 16. Our original function was not in terms of y, so here is where I have to do that extra step of writing the correct notation. So my final answer is f inverse of x is equal to 2x minus 16. For number 2, we are going to do the same kind of process. We have been given a f of x function. We want to algebraically determine if this is a one-to-one function, and if it is, we could move on to part B. So let's start with A. So if I'm showing algebraically, I need to do f of A equals f of B. I'm substituting a squared minus 4 equals b squared minus 4, trying to get that a equals b, cancel by adding 4. At this point, square root both sides. And we end up at positive or negative a equals positive or negative b. We saw this case in our previous lesson, so we already know. Let's see, therefore, a function that is not one-to-one. Since I have this case of it's not a one-to-one function for part B, what I have to say is that f inverse of x does not exist. We can actually make it exist, but we would have to restrict the domain. And at this point, we're not going to do that just yet. So let's look at example number 3. So here is number 3. We are going to do the same kind of process, go through the algebraic piece, and then find the inverse, if possible. Part A, we're algebraically determining. For part B, we're actually going to find the inverse. So let's start with part A. So I have a g of x function. I'm going to say g of a equals g of b. My goal is to prove a equals b. At this point, I'm going to cube root both sides. And unlike the square root, the cube root is going to take the sign of the radicand itself. So in this case, my a was positive originally and my b was positive. Therefore, my answer would be a equals b, positive a equals b. Since I'm able to show that, I can say that we have a one-to-one function. Now that I have a one-to-one function, I could do that extra step of finding the inverse. So for part B, I'm going to start by changing my equation in terms of x and y. I'm going to swap at this point and solve for my new y. To get rid of the exponent of 3, I'm going to cube root both sides. And there's my answer, but again, I have to make sure I write my answer in correct notation. G inverse of x is equal to the cube root of x minus 3 over 2. Let's do another one. Here we have our given function h of x, algebraically determine if you have a one-to-one function, and then we want to find the inverse if possible. First thing I'm going to do is my algebraic proof. In this case, h of a equals h of b. Substitute your a's and b's. All right, so now I am trying to get to a equals b piece. First thing I want to get rid of is the exponent of 5. So how am I going to get rid of that? I am going to fifth root both sides. I got rid of that exponent. Next thing I'm going to do is get rid of the denominator of 8. So how would I do that? I will multiply by 8 on both sides. Okay, so I'm up to the easier part. Plus 4 on both sides knocks that out. I'm left with the 7th root. And to get rid of that 7th root, what we would do is raise everything to the 7th power. Anytime you are taking the root of an odd number or raising it to an odd power, what happens is that you're going to get whatever the radicand was. So again, in this case, a equals b. Therefore, one-to-one function. Now that I have a one-to-one function, I can go ahead and find the inverse of this function. So I'm going to rewrite it in terms of x and y. I'm going to swap it now. And I'm going to solve for my new y. So the first thing I need to do is, again, get rid of that exponent of 5. And the only way to get rid of it is to fifth root both sides. We are solving for y. So what are we going to do? I'm going to do kind of the same process that I took with the algebraic method. I'm going to multiply both sides by 8. All right, I am going to add 4 to both sides. So at this point, we're going to get rid of the 7th root by raising everything to the 7th power. And that is it. So for this one, we have been given a rational function, a of x. We want to algebraically determine if this is a one-to-one function. And then if it is, find the inverse. So let's get started with part A. Okay, so I'm going to use different colors here since in a function I don't want to get mixed up. A of A is equal to A of B. There's my substitution piece. At this point, I am going to try to solve for A equals B. The only way for us to do this is to go back to cross multiplication. So I'm going to do that here. I'm cross multiplying or setting myself up. So this would be my setup. At this point, I could clearly see I need to do some foiling, and hopefully that helps me get to A equals B. There's my distribution. At this point, our goal is to get A equals B. But before we get there, let's see if we could cancel out anything. So I could clearly see I could plus 18 on both sides. That will get knocked out. So that's gone. I also see that if I minus 6AB on both sides, that too will cancel out. Right now, what I'm left with is 4A minus 27B is equal to negative 27A plus 4B. We're going to put all the A's on one side and all the B's on the other. So at least I'm almost getting to the point of A equals B. This actually did get me somewhere nice because I get 31A equals 31B. At this point, what would I do? Divide by 31 and I end up at A equals B. Since I'm making it to A equals B, I could conclude that this is a one-to-one function. I know this is a one-to-one function, therefore I could find the inverse. So let's find the inverse of this function. Again, I am going to rewrite this in terms of x and y. I'm going to do my swap. Okay, so I see a little bit of an issue here because I have y's in the denominator and numerator. So I'm going to take the process that I did in the algebraic proof. I'm going to cross multiply. I'm going to distribute. And now I'm going to try to move those y's together. So let's move the y's together and I'll move this x to the other side. I know that I could put them together. The y's are in one side. They are not like terms, so I can't make them look any nicer than this for right now. At this point, since my y's are on the left side, both of these terms have a common y, a GCF of y. So I'm going to factor out the y. And this is great for me because since I'm able to do that, I can now get that y by itself. Again, don't forget, what is it that our function was originally? A of x. So I'm going to say A inverse of x is equal to, and that is it. So the more intensive questions are questions like number 4 and number 5 that we did. These are the more pre-calc level questions. You will always need to algebraically determine whether a function is one-to-one before you're able to find its inverse. So keep learning, keep growing, and I will see you in our next video.